Welcome back. Let's look at the following equation. Let's say we have 4x minus the expression 2x minus 7, and this equals x. Okay, notice we have x's on both sides of our equation. Now, just because we see our variable alone on one side does not mean our equation's solved, because x shows up on the other side as well. This isn't anything to write home about. We'll simply just move our variables to one side and everything else to the other side and go about business as usual. So let's start off by distributing this minus sign into our expression. Now we saw in a previous exercise that when we distribute a minus sign into an expression, all we're simply doing is changing the sign of each term in the expression. We can also think of it as we're multiplying each term by a minus 1. Okay, so let's do that. We have a 4x right here minus 2x, minus and minus is a plus, 7 equals x. Okay, now we want to get our variable on one side and all the other nonsense on the other side. So actually we can go ahead and combine these two variables. 4x minus 2x is 2x plus 7 equals x. Let's go ahead and subtract 7 from both sides. Let's move all the variables to the left. This will give us 2x plus 7, negative 7 cancel. So 2x equals x minus 7. X minus 7. And all we have left to do is to move this x to the other side. So we have a positive x, so we're going to subtract x from both sides. Just taking things one step at a time, using what we know. We're canceling this out. 2x minus a 1x is a 1x, or just x, equals minus 7. So x equals minus 7 is our answer. Okay, so even though we saw that our original equation was already solved for x, we had x's on the other side, so we actually weren't done at all. So there was work to be done. And we can also plug this minus 7 in for all three of these x's, and this equation should hold true. If it does, then we have a valid solution. Let's go ahead and look at another example. Let's say we have z, changing up variables, we have z minus 2z divided by 5 equals a minus 3 over 7. Okay, so we got a couple z's over here, but we can't combine them because this z is buried inside a fraction. And so we're going to have to manipulate it a little bit before we can work with it. Let's go ahead and copy this z, and let's rewrite this 2 over 5 times z. We're going to separate the rational number from our variable, and we can actually see a little easier that we can work with this. We have a variable and a variable, and all we're doing is subtracting a rational number. Let's subtract the coefficients. This z has a coefficient of 1, but let's go ahead and write it as 5 over 5z. So we have a common denominator here, and we can simply subtract. So this gives us 5 over 5z minus 2 over 5z equals 3 over 5z. And we still have our minus 3 over 7 on the other side. And we have one more step here. Our variable is being multiplied by a fraction. So what we're going to do is we're going to multiply by the reciprocal. So 5 over 3 is the reciprocal of 3 over 5. Then we still have our 3 over 5z equals minus 3 over 7. We have to do the same thing on the other side. Multiply by 5 over 3. That keeps the balance in our equation. This fraction cancels with this fraction. We're just left with z. And over here we have a negative and a positive, so it's going to give us a negative. 3 times 5, or actually, well, let's go ahead and simplify this a little bit. This 3 can cancel with this 3. So we have 1 times 5 is 5, divided by 7 times 1 is 7. So z equals a minus 5 over 7. We almost missed simplification right here, but even though these numbers aren't very big and they're not very difficult to deal with, we want to get in the habit of simplifying as we go so we can make our calculations a little bit simpler. That's why it's called simplifying. Let's take a look at another one. Let's say we have y over 4 plus y over 9. And this is going to equal minus 5. Okay, so what do we do here? Well, we can rewrite this just as we did above as fractions with our coefficients as fractions multiplied by the variable. It's pretty much the same thing. We can write this as 1 over 4 times y plus 1 over 9 times y. And we can see that this works because if we multiply 1 over 4 times y, or we're simply multiplying by y over 1, so we multiply the numerators. So 1 over 4y is the same as y over 4. And the same thing goes with y over 9. Okay? And we have minus 5 on the other side. All right, now let's go to the side and find a common denominator. We need a common denominator so we can actually add these two variables here. So we have 1 over 4 plus 1 over 9. Let's figure this out. So let's do cross multiplication. We have 1 times 9 is 9, plus, it's our plus sign, 4 times 1 is 4, and the denominators, 4 times 9 is 36. This is 13 over 36, so we have 13 over 36y. Okay, we did this, and actually we've done it a few times in previous videos, adding and subtracting rational numbers and instead of finding common denominators. Actually, we just did it with variables as well, and we can see that it actually works the same. Okay, so and on the other side we still have our minus 5. Now we just have one more step. We have a variable multiplied by a rational number, so we're just going to multiply by the reciprocal. 36 over 13 times 13 over 36y. We have our minus 5 on the other side, and we have to also multiply the other side by the reciprocal, 36 over 13. Okay, this cancels with this. We're left with only y on the left side. On the right side, we have minus 5 multiplied by 36 over 13, which is a minus 180 over 13. And that's our answer. Be sure to check our answer when we by substituting in minus 180 over 13 and for our variables up here. The multiplications, like I said, can sometimes be a little ugly, but as long as they work, that's what we're aiming for. I think we have enough time to do one more. Let's see. Let's do 3x plus 1 divided by 8 equals 1/2. Okay, we saw an example like this earlier. We have our variable buried inside the numerator of a fraction, so what we can do is we can multiply the fraction by the denominator, which will be able to cancel our 8's. And we can do this without changing anything if we multiply the other side by 8 as well. So that'll leave us with 3x plus 1. It gets rid of the fraction bar here. That's what we want. 1/2 times 8 is 8/2. It's multiplying the numerators here. All right, let's go ahead and move our 1 to the other side. Plus 1. We can subtract 1 from both sides to cancel out. Give us a 3x equals, let's go ahead and change 8 over 2 into 4. And minus 1. Which gives us 3x equals 3. And then our last step is pretty simple. We divide both sides by 3. That'll cancel out the coefficient of x and just get x by itself. And 3 divided by 3 is 1. Okay. So we're out of time here. Go over and a good review when we're doing multi-step equations or just any equations in general is plugging these answers back into the variables to make sure that we indeed got the correct answer. I'll see you in the next video.